Hello everybody, I'm Dragos, co-founder of InsidAR, and here is how we can make a basic localization app using it. InsidAR is a library that works over existing SLAM systems. Right now we have integrated it with AR Core, and pretty soon ARKit will also be available. First, scan the place you want your user to be localized inside. Check out the limitations page inside the documentation for limitations and thresholds. For scanning, you don't have to write any line of code, just use InsidAR's scan app, and once you have enough data, upload it to our cloud. Right now we have two ways of handling this, having one sole scan on which you can find yourself, but beware on places that look similar or scans that are way too big. The other way of handling this, for instance for something like a hypermarket, is storing a scan for each aisle. Use our image-based coarse localization, and once we know on what aisle you are placed, you can localize yourself more exactly using our 3D scan-based fine localization. Inside our scan app, you can also test the localization, place some pins, upload them to cloud, and then when we reopen the app, we can relocalize ourselves and see if they are placed well enough. Scan app allows you to do this step by step, but in your own app, you can automate the process as much as you need. Okay, now that we know it works, let's make a client app. We'll have an app that localizes you inside the test scan and downloads the pinpoints whenever it does. So in order to make a client app, this is what you should do. Open a new Unity project, import AR Foundation and the AR Core or ARKit Unity XR plugin. Since it's still in the preview version, please make sure the versions are good so you can check the documentation for it. Switch the platform to Android. Make sure you check allow unsafe code. We do this because we take the images from the AR camera, and for this we use a pointer, and that's what they consider unsafe. If you're on Android, you should set the minimum via API level to at least 24, set a correct package name, add an AR session and AR session origin to scene, delete the default camera. And now you could either use our prefabs or you could do this manually. So you would add an AR session origin to scene, add an AR point cloud manager component to it, and select the AR camera and set the tag to main camera. Then all you have to do is drag the InsidAR manager prefab in the scene, drag the AR point cloud manager to the empty attribute inside feature point extractor script inside AR manager, and drag the AR camera on the camera image manager script. And now all you have to do is set up the API key inside the InsidAR manager script. So right now it should work as it is, and we should look a bit on how to implement a small program in which we scan around and then we try to relocate ourselves, and then we should download the pinpoints we uploaded through the scan app before. Let's look a bit at the example scene. Here we have two buttons. On pressing one of them, we will start or stop scanning. The 3D scan is the object that will be sent to the cloud and compared with the main scan we did at the first step. After we have enough points, we recommend at least 500, you can ask the server to localize us. All these 3 steps can happen inside the same function with just one interaction, but we separated it like this so you, the programmer, will understand the workflow. So now we'll enter the code to see what each part does. First of all, at start time, we will take all the names of all the scans we have right to access. Most API calls can be made through Network Manager class, which is a wrapper for most calls. Here is how we get all the names. For switching the scan state, we simply call feature points extractor .switch should scan. That's the second class we're interested in, and it's the class that handles the 3D scanning part. The scan is stored inside cubic scan class. While scanning, we can easily see how many points there are by getting cubic scan.filtered scan points. There are the points that we decided after processing that we should also keep. For getting our offset inside the big scan, we'll just ask the API to match our scan. For this example, we will match to whatever the first scan we have, but you should be more specific than this for most use cases. In the end, we simply wait for the event on scan matched, and here we have a XYZ translation offset and the rotation offset. All we have to do now is give this offset to a direct child of AR session origin we called world parent, and make sure all the localized objects are now relative to this. Theoretically, now that you know where in the big map you are, you can do most things you want. However, for the ease of use, we also offer you a CRUD for 3D pins that are added inside InsidAR scan app, and also to be easier to debug if the match was done correctly. All you have to do immediately after matching is to call download anchors. We'll receive a list of offset anchors that we will parent by world parent, and make sure we set the local position to it. So that's it. But to have a better idea of how it works, we also offer you the debugging tools we used while developing. They will definitely look better in the future and have more functionality based on your feedback, but it gives us a good insight on how it works behind the scenes. Here we can see a 3D scan and see if the pinpoints are placed well, and even add, edit or remove anything we want. One minus is you have to guess what is what right now based on the shape and color. We can also see how well our test scans are matching. We decided to share this with you so you can understand what the limitations of relocalization are right now. If something is wrong, just check out the limitations page so you can see what could be the problem. It would also benefit us greatly as well if you'd share what you're doing with us, what's working and what not, so that we would know exactly on what to work as well. Please don't hesitate to contact us for anything. Have fun!